Good evening, guys. So I see like still many people are joining in. So, all right. So as usual, then we will wait for some time. Let's say 5 minutes, and we shall start today's session by 7:05. Okay. But in meantime, guys, if you have any questions so far that we have seen so many tools, practices over the last 6 days. So if you have any questions, so please do not hesitate to ask them. You can use the chat window to put down your questions, and I will answer them one by one once we resume the session by 7:05. So till the time, let's wait and let's give an opportunity to other people to join in. All right, so we will start by 7:05, guys. Please keep your questions handy or post it in chat window so that you can ask and I can clear your doubts. Thank you. All right, guys. So let us start for today's session. And today we're going to talk about Kubernetes. So before we start, do we have any doubts, guys? Any doubts from previous sessions? Hello, everyone. Do we have any doubts, guys? So I'm not hearing from anyone, so I will assume that no one has any doubts. Okay. And having said that, so let's start for our today's session, guys, which is Kubernetes. Okay. So now, before we talk about Kubernetes, let us understand why we need Kubernetes. Okay. So understand, guys. So Kubernetes is another category from container management family or container orchestration family. So we have already seen one tool from container orchestration family, which was Docker Swarm. Then the question arises, if we already have Docker Swarm, why we need Kubernetes? Okay, so there are many differences and many advantages which Kubernetes provides, but telling you very quickly. So first of all, if you want to understand what is the difference, so Docker Swarm obviously is a product from the Docker itself, the Docker Corporation, which has already another container runtime owned, which is Docker itself, and the container orchestration tool as in Docker Swarm. Okay, that is one. So obviously, as it is a proprietary tool, Docker Swarm has a native compatibility with Docker Container Runtime. What do we mean by native compatibility? So by native compatibility, we mean that Docker Swarm can manage or orchestrate the containers which are launched using Docker only, as in Docker Container Runtime only. It cannot manage containers which are launched or managed by another container run. That is first. Then second, if you want to use Docker Swarm at an enterprise level, it does not come free of cost. As it is a proprietary tool, you have to pay some certain cost, some certain licensing cost based upon your usage. Whereas, on the other hand, if you understand Kubernetes, Kubernetes is an open source tool. Okay. Basically, Kubernetes, we call it as an brainchild of a Google. What do we mean by brainchild now? So basically, Kubernetes, the development of Kubernetes is taken care by Google itself. But Google donated this Kubernetes as a tool to CNCF Foundation, meaning Cloud Native Computing Foundations, which is basically a foundation which sets principles and controls how cloud should be governed and how cloud should be grown. So there are many cloud providers. If you want to be one of the cloud provider in nearest future, then obviously you need to make sure that you are complying with all the guidelines and compliances established by CNCF. Okay, so Google has donated this Kubernetes to CNCF Foundation, and it is controlled by CNCF Foundation, but the actual development part, the product roadmap and the development part is being done by Google. So that's why we say it as a brainchild of a Google. So despite Google is developing it, as it is controlled by CNCF, it is free of cost. Okay, it is completely free of. So what do we mean by free of cost? We don't need to pay any amount. We don't need to pay not even a penny in according to use Kubernetes. Okay, that is first. The first advantage over Docker Swarm. The second advantage over Docker Swarm, which Kubernetes provides, is obviously Kubernetes can manage containers which are deployed using different container runtime. Okay, so not only containers which are deployed using Docker as a container runtime, but you can even use containerd or cryo as an open source container runtime. Okay, so that your cost will be almost zero if you want to manage containers being deployed by containerd or cryo. Okay, so these are two practical advantages, and there are many more advantages. So I'm not going into too much depth of Kubernetes advantages over Docker Swarm. You can for sure go ahead and have a look at the differences, okay, on the website. So having said that, let's go ahead. Let's go ahead and let's understand how the architecture of Kubernetes is being managed. Okay, let us understand how Kubernetes has been architected. Okay, so I'm sharing my screen. I hope everyone can see it. Can everyone see my screen, guys? I'll assume yes. So now let's go ahead and let's talk about it. So just like Kubernetes, just like Docker Swarm, Kubernetes also uses cluster to get installed. Okay, just to make sure high availability and all other things that we used to that we need to maintain. Okay, and we have discussed this in very detail with Docker Swarm itself. So the same attribute to make sure Kubernetes also gets installed with the clustered mode. Okay, so now let's say if this is your cluster. Okay, let's say this is your Kubernetes cluster you may have installed on premises or on cloud anywhere. So basically it also consists of two different kinds of nodes. Okay, it also consists of two different kinds of node. So just like Docker Swarm, there are two nodes, two types of nodes basically. Okay, now this node, let's say this is your cluster. This node, we will call this node as an Kubernetes master or KHS master node. Okay, and these kind of different nodes where actually your container would be running, we call them as an either simply by node, or we call them as an minion. Okay, we call them as an minion. Okay, so minion is an older terminology, so it has been now deprecated by node. But don't worry, I'm just introducing you to these both of the terminologies so that if you ever came across any tutorial which has mentioned node as a minion, so don't get confused. Basically, minion means nodes only, your worker nodes only. Okay, so you can refer them as a minion or as a node, but nowadays popularly we identify these nodes and these minions as a node only. Okay. Now, in this cluster, all these minions and nodes have some certain, and this master have some certain components. Okay, some certain components which are getting installed. So first of all, let's get familiarity with these components. So when you say about master, so there are basically 5 components which are getting installed in master when you install that. Okay, so first is etcd. Okay, the first component is etcd, etcd, or you can even call this as an etcd. Okay, second component which gets installed is basically controller. Okay, so controller manager. This is the second component which gets installed. Then third component which gets installed is cloud controller manager. Okay, cloud control manager. Okay, we will talk about the roles and responsibilities of all these components, so don't worry about it. Okay, now third or fourth component which get installed is basically scheduler. Okay, scheduler. And the last component which gets installed is basically API server. Okay, API server. And on every node, there are basically two components which are getting installed. Okay, so the first component which is getting installed is kubelet. Okay, kubelet. And the second component which is getting installed is kube proxy. Okay, kube proxy. And obviously any container runtime would obviously already been there. So when I'm saying container runtime, I'm referring to either Docker or Cryo or any other component. Okay, so basically this is how your Kubernetes cluster looks like. Now let us understand what are the roles and responsibilities of all these components in a Kubernetes cluster. So first of all, understand, just like we used to give some kind of instructions, to our Docker cluster, just like that, we will be instructing Kubernetes cluster to run some certain commands, to run some certain containers, or to auto scale, to downscale, and so on. Okay. So there are all these things we will be telling to the Kubernetes cluster. So how we will be telling Kubernetes cluster, right? So understand one thing: you can host your Kubernetes cluster anywhere, on premises, or on any cloud provider. Okay. Or nowadays there are many managed services. Every cloud provider is providing Kubernetes managed services. For example, AWS is providing EKS as an elastic Kubernetes services, just like Azure is providing Kubernetes Playground, GCP is providing Kubernetes Playground, right? So just like that, every cloud provider is also providing your managed service for Kubernetes cluster, so that you don't need to install it anywhere. Okay. Having said that, we will be working from our workstation, from office, or from your laptop. So obviously we will be writing down some scripts. Okay. Some script, and we will be asking Kubernetes to execute it. So how we will write down these scripts? So basically we will have to write down these scripts in a YAML definition file. Okay, YAML definition file. And these scripts, we will call them as an KS specification script, basically Kubernetes specification script. Okay. Now, if you are wondering what is this KS, so basically Kubernetes. This is Kubernetes. So Kubernetes is also called as an KS, or you can even say abbreviation or a short form. KS is an abbreviation or short form of Kubernetes, and there is no logic behind it. Very simple. Why KS become an abbreviation for Kubernetes is between the starting K and ending S. Okay, there are 8 alphabets, like 1, 2, 3, 4, 5, 6, 7, 8. That's why it became KS. Okay, so that's how people are abbreviating it. So coming back, so we will be writing down these Kubernetes specification scripts or Kubernetes scripts using YAML. Okay, using YAML. So when we are writing down these scripts, obviously we will have to execute them. We will have to execute them using something. So that utility is called as an kubectl. We will use kubectl to execute all the scripts. Okay, kubectl, or you can even say, you can even name this as an kube control, kubectl, or kubectl, whichever is like convenient to you. You can use any name, right? Either kubectl, kubecontrol, or kubectl. Okay. Now, when you are saying this, you need to understand one more thing. Once you write down your Kubernetes scripts, okay, we will come back to the scripts to understand how it is being written and everything. But for example, you have written down some script, some Kubernetes scripts, okay, using some Kubernetes objects and something. Now, when you will ask this Kubernetes cluster to run all these things, so what happens? This kubectl utility is going to call the APIs which are hosted in this kube master, this Kubernetes master. Okay, so basically this kubectl utility is going to call that respective API. Okay, Kubernetes provides multiple APIs. So depending upon your Kubernetes definition file, which Kubernetes object which you may have used, it's gonna go ahead and it's gonna call that API. Okay, once the API is being called, now what will happen? What will happen? This Kubernetes master will try to run some pods, some services, or some deployments, or do some action. So where that action has to done, let's say you want one container to run. Okay, you want one container to be replicated, you want one container to be scaled out, right? Whatever operation you want. So basically, what is going to happen? What is going to happen? This API server will go ahead and will ask your scheduler, or it will ask your Kubernetes master to run that. And then what your Kubernetes master will do, when I'm saying Kubernetes master in this scenario, if you have installed or configured your Kubernetes on premises, then this control manager. If you have installed it on cloud, then this cloud control manager, right? Depending upon where you have installed, any one of them will come into picture and it will decide where to run that particular pod or whatever action has to be done. It will decide. And how it's gonna decide? Very simple. It will look at this HCD. What is this HCD? HCD is nothing but HCD is nothing but a key value. HCD is nothing but a key value pair database. Okay. What do we mean by key value pair database? So this key value pair database will be looking something like this. Okay. Let me just delete it. Let me recreate it. Yeah, this key value pair, what it will contain, let's say, for example, it will contain, this is just an example I'm giving you. It actually contains much more information. Let's say node, okay, and let's say pods or any other things which it may run, okay. Okay, nodes or pods. Let's say, for example, it will store something like this. Okay, it will store something like this. So node number 1 contains 3 pods. Okay, something like this. Node number 2 contains 4 pods, so that it will store all the information about the cluster, how many pods or how many services or how many deployments are running in your master and where they are running, so that at any given point in time, your Kubernetes master can identify if it has to run new containers or new pods or new deployments or services, where that has to be run in according to make sure that your load is evenly getting distributed across the complete Kubernetes master. Okay, your load should get evenly divided across all the worker nodes. Okay, that's what the benefit is. Okay, now that's what the HCD stores. That's what information HCD stores. Okay, and for your information, HCD is also known as an key value database for operating system. Okay, now depending upon your status of your Kubernetes cluster, it will decide where to run, and basically it will pass on the instructions to that respective worker node. Okay, so when I'm saying it will pass on the instruction to that respective worker nodes, meaning what? It will ask that respective worker node to run that or to complete that particular operation. Now, who will do that? So that's where this kubelet utility comes into picture. On every worker node, this kubelet utility has been installed. You can imagine that as an agent. Okay, it will receive some instructions from master and it will execute it on local. It will execute it on that particular local machine, and it will give back the result to this master, whether the operation has been successfully done or not, and rest of the information which is required. Okay. Now, once your operation is done, what is the role of the scheduler? This scheduler will run on intermittent basis. It will run intermittently and it will check your HCD and it will also cross verify. Let's say this node 1 should contain 3 pod as per the record. So it will go and it will check. Is it, does it really contains those particular number of pods? Okay. If no, then it will do all the necessary actions which are required to make it to meet the status which is already recorded. Okay. That's what the responsibility of scheduler is. Okay. So in a nutshell, this is how basically your Kubernetes cluster will work. Okay. Very much similar to your Docker Swarm itself. Okay, but there are more components over here. And there is one more fundamental difference with the Docker Swarm and Kubernetes is, in Docker Swarm, your containers may run on your Docker manager. Okay, whereas in Kubernetes, your Kubernetes master does not run any container anytime. It won't run any container anytime. It doesn't matter. Okay, so what do we mean by that? To set up a Docker Swarm cluster, one machine, at least bare minimum one machine is required. But to set up a Kubernetes cluster, there are at bare minimum 2 machines are required. Okay, bare minimum 2 machines are required. Okay, so that's how this Kubernetes master is being set up. Okay, so before we move on, guys, everyone is clear with the Kubernetes architecture at high level? Anyone has any doubt so far? Yes, you can unmute. Bhargav?
Yeah, so the chat window has been disabled for us. So, I mean,
Oh, is it?
yes, that's the reason why I.
No, let me ask then. Amar or Natarajan, can we please allow chat window for people to post the message and everything?
Yes, everybody access to chat window.
Okay, can you try now, Bhargav, if you have any doubts or concerns? If someone cannot put your questions in the chat, then please feel free to quickly unmute yourself and they can ask your question, please. No questions at all? Shall I move on then? Perfect. All right. So then I will move on. So before, we actually see the examples of Kubernetes, I will actually show you how basically we can go ahead and how we can install Kubernetes. Okay. So there are multiple ways to install Kubernetes. Okay. So the first way is installing Kubernetes on-premises. Okay, so if you want to install Kubernetes on-premises, what you need to do, you just need to go to website kubernetes.io. It's an website of Kubernetes, official website of Kubernetes. You can head back to documentation over here. Okay, and you can follow this link, set up KTS cluster. Okay, so just in the interest of time, I cannot go ahead and show you the complete installation of Kubernetes cluster right here, right now, because we have very little time to look at the Kubernetes at a high level. So I will skip the complete detailed installation of Kubernetes. Generally, it takes somewhere around 30 to 45 minutes. Okay, so I will skip that, but I will guide you that you can go here. Okay, and you can simply set up Kubernetes over here, and this is the complete documentation. Okay, you can go ahead and you can follow. There are many steps. You can follow one by one. Okay, basically these 4 steps are there. You can follow one by one, and your Kubernetes cluster will be installed on your local laptop. if you want to install it on local laptop. Also, please note that in according to install Kubernetes, you at beforehand must have installed any Docker runtime, any container runtime like Docker or Containerd or Cryo. Okay, all those things are nicely explained in this documentation. So please feel free to follow that. Then second, there is a prerequisite. There is bare minimum hardware requirement which Kubernetes requires. For example, it requires two virtual CPUs at least in a machine, and bare minimum it requires 4 GB RAM. Okay, that's the prerequisite for Kubernetes in hardware in terms of hardware capacity. Okay, so please make sure your hardware meets the requirement, and then please move on with the installation. Here is the link on Kubernetes. I will show you one more time. Go to kubernetes.io. Here's the documentation, and you can simply go ahead and follow this Kubernetes setup. Okay, now this is one thing. Okay, if you want to install Kubernetes on premises, if you want to install, or if you directly want to take leverage or take benefit of the managed cloud provider, then you can go ahead and you can open your free tier account. You can open your free tier account with any cloud provider like AWS or Azure or GCP, and all of them are providing basically a managed service for Kubernetes. Okay, so as we have chosen to use AWS since beginning, so I'm telling you how you can go ahead and how you can configure EKS cluster on Kubernetes on AWS. My bad. So just log into your AWS account. Okay. Go search for EKS. Okay. You can simply use this search box to search through services. Type EKS, and you will be able to see Elastic Kubernetes services. Okay. So click on this. And you will come over here. I have already configured the EKS cluster because to provision and configure EKS cluster, somewhere down the line, you will need 20 to 30 minutes. Okay. So again, to save some time, I have configured my cluster at beforehand only. Okay. But how to configure? So please, I'm explaining it you now on Amazon. First of all, you will have to create 2 roles. So go to services. Okay, do not do anything on Kubernetes. Okay, go to services and click on IAM, or if you cannot see it, just search for IAM, which stands for Identity and Access Management. Okay, go to IAM. Okay, and you will have to create 2 roles. You will have to create 2 roles. So first of all, click on these roles at your left hand side. Create first role. Okay, you will be able to see something like this, and you need to search for over here. You will see use cases. You will see the quick option EC2 and Lambda. Don't go for that. Just go for EKS first. Search your EKS, and you will see the second option, EKS cluster. Choose this. Select this. Okay, select this, and then say next. Say next, and give your role name, something like EKS cluster role, something meaningful, EKS cluster role. Okay, and review everything and simply click on create role. It will create one IAM role. Okay, so I'm canceling it because I have already created it. This is first role you will have to create. Then again, click on create role. And now this time you will have to choose EC2. Okay, you'll have to choose EC2. Okay, now go next. And over here, you will see all the policy and permissions. So first of all, search for EKS. And you will see, once you search for EKS, you will see Amazon EKS worker node policy, this one. Okay, second one, Amazon EKS worker node policy. So select this. Okay, select this. Okay, this is first policy you will have to select. Then search for container, and you will see container registry read-only access. Amazon EC2 container registry read-only access. Do not give full access, just go for read-only access, which is sufficient. Okay, select this second policy also. Okay, then search for ENI. Again, go for container and we shall be able to see ENI policy. Okay, not here. Okay, so these two policies you will have to select. There are basically three policies. I'll tell you the third policy name also. There are, we have selected two. Then simply say next. Okay, give you again the second role name, for example, worker node. All right. And simply say create. You will have to add again, you will have to add third policy, the name I'm telling you shortly. Okay, but make sure you are adding these two and the third policy, which I will tell you shortly. Okay, and say create role. Okay, so we have created two roles. First is EKS cluster and second is this worker. Okay, so the third policy I'm telling you, this Amazon EKS CNI policy. Okay, first is worker node policy, container registry read only, and EKS CNI policy. This is something you will have to create. Okay, in a role. Once you have created these two roles, okay, in our case, we have given role name as an EKS, first role name as an EKS cluster. Okay, second role name we have given worker node. Okay, now once you are done, come back to your Elastic Kubernetes Services EKS, okay, as a service, and add, say, create cluster, give your cluster name. I'm saying EKS cluster or my cluster or your product name, whatever meaningful name you want to give. Give that, say next, and over here, you need to make sure one thing, it should auto-populate the role. The first role which we have created, basically EKS cluster role. Okay, it has all the required permissions. Okay, so if it, because of some reason, if it does not automatically populates, so please make sure to select it. Okay, the EKS cluster role which we have created first time, then say next, choose default options only. You don't need to go haywire to start with. Say next, next, review everything and say create. Once you hit on create, it will go ahead and it will launch your EKS cluster, which might take somewhere 10 to 15 minutes. Okay, once your cluster is ready, okay, ready means what? You will be able to see something like this, your cluster name and active. Okay, once your cluster is ready, go back to click on your cluster. Okay, click on your cluster and go back to compute. Over here, compute and nodes, because I have already added that, I can see the nodes. Else you will be, as you will be launching it first time, you won't be able to see any nodes because I have already added it. So in worker node groups, over here node group, just click on add node group. So I'm clicking on add node group. Now here, give your worker node group name, any good name. Okay, and over here you need to select our second role which we have created for worker node. So if you click it, you can see the worker node role which we have created second time. So that role, make sure you're selecting that role. Okay, and then again say just go ahead next. I'm giving some name. Next, choose whichever operating system you want, but the default one should be sufficient. Okay, choose your instance size, what kind of instance you want. Okay, I'm keeping it T3 medium, which is bare minimum. And then say next, choose your network, say next, review all the options. And once you are at the last page, once you reviewed everything, simply say create. Okay, and what it will do, it will add the worker nodes into your EKS cluster. And once they are ready, you will be able to see something like this. Your worker node basically is ready, is active, and you can see the number of machines which you have added just now. Okay, so this is exactly how you will have to create your worker nodes. Okay, on an EKS cluster. Is this clear, guys? Okay, so if you want, you can always revisit to all these steps if you want to create. Okay, so you will be having access to the recording in LMS. So please make sure when you are configuring it on EKS, you can refer to the recording step by step by pausing it. Okay, whenever you need. Also, there is one more important thing which I would like to tell you. Very much important thing is, first of all, despite you are creating a free tier account, with any cloud provider. Doesn't matter. This EKS service, it is not free. Okay, you will have to pay some certain amount for that. Okay, so please, once you are done with the practice, make sure to delete your clusters and something. Okay, whatever resources you may have created, how to delete that? Simply select the cluster, okay, and click on delete. It will delete the cluster as well as the worker node which you may have created. Okay, is this clear, guys? I hope it is. And now, once you are done with all those things, okay, you will have to make sure that you have installed kubelet. Okay, on your local machine. So how to install kubelet? Go back to your kubernetes.io and you can see something like this. Install kubectl on Linux, Mac, or Windows, whichever operating system you are using. For Windows, just click on Windows and there are two options. Follow any one option, okay, and you will be installing kubectl. Okay, so install this kubectl on your operating system, and once you are done, you will have to configure your kubectl so that your kubectl can communicate with this Kubernetes cluster, which we have set it up on Amazon. So the basic command is to configure kubectl. Before that, you will have to install Aws CLI, because now you are communicating with Kubernetes EKS cluster, okay, on Amazon. So just simply download Aws CLI. You can see aws.amazon.com/CLI. Here is the URL, okay, and simply download the installer from this website, from this documentation. Once you download that, simple installer will get downloaded, simply an wizard, just like you install any other tool on Windows. Simply install that, and what you will have to do is go back to your AWS account, click on security credentials, okay, and simply create your security credentials from here. Okay, create access key. It will create an access key. Download that access key. Okay, all right. And once you are done that, simply come here and type AWS configure this command, and it will ask you for the access key and secret key. Provide everything, and that's fine. Okay, once you are done with this, simply say kubectl, okay, kubectl get svc, and it shall able to tell you that, okay, your Kubernetes cluster is up and running. So once you see the output, it means that you have installed and configured your Kubernetes cluster and kubectl utility successfully. Okay, so this is a installation of Kubernetes, which you will have to do. Unfortunately, it's not that easy. Just like we used to see with any other tools which we have seen so far till now, the installation of Kubernetes cluster is not that simple, unfortunately. Okay, but it's one-time task, so that's okay. All right. Now, if Everything is clear till now before we move on, guys? Do we have any questions? All right, I have 2 questions. So could you please repeat everything once? Okay, so you can always see the recording. If you want to revise any particular thing, so you can always see the recording. So I guess that will be more helpful. Someone is asking what is pod. Okay, we will see that shortly. Just hold this thought for a minute. Okay, someone is also saying, could you please advise? Okay, what exactly you want to ask? I guess Bhargav, you asked this question. Could you please advise what exactly you are trying to ask? Your question is a little bit unclear. Can you hear me, Bhargav? Okay. All right. So you want advice on learning AWS? There are lots of options. There are cloud is something like something different topic. Okay. So you may would like to go ahead and you may would like to connect to our LMS team or our support team. Okay, and they will be able to guide you through. Okay. And these are not a lot of options. Basically, these are all the services which Amazon as a cloud is providing you. Okay, so please make sure that you drop this particular query to our support team, and they will be for sure happy to help you on your learning. Okay, so as of now, even on the call, our other support team members are here. So Amar and Natajan, if you can just take a note and connect to Bhargav post call or something, and you can help Bhargav with on cloud learning, that would be really nice. Okay. So guys, please don't unmute yourself if you just want to snore. Okay. Amar, can we please mute all the participants permanently?
Yes, 1 minute I will.
Thank you. Sorry guys, there is some kind of disturbance. Okay. Now, kubectl installation did not understand. I think it's locally installed. No, we haven't installed it locally. So we have installed Kubernetes cluster over the cloud, on cloud. Okay. Only kubectl is the part which we installed locally. And how do you install it? Just go back to your Kubernetes website. Okay. And you can see this kubectl on Windows. Okay. So there are 2 ways you can install kubectl on Windows. This is first way. The instructions are given over here, or this is the second way. This is the second way. Okay. So follow any one of the way, first or second, and that should be okay. Okay. It will install kubectl on your local. All right. I hope that is clear. All right. I'll assume this is clear. So now, before we move on, you will have to understand something. Okay. What we say Kubernetes objects. Okay. So basically, there are many Kubernetes objects, 4 or 5 objects in day-to-day life you may be interacting with. Okay. So first is something called as an pod. Okay. Another, it's something called as an replica set. Another is called as an deployment. Another is called as an services. Or okay. Now these are 4 important Kubernetes objects. And most of the time you will land up using any one of them. Okay, so you need to understand one thing. Okay, first of all, in Docker, in the Docker analogy, in the Docker terminologies, the least entity we can interact with was container. Okay, the least entity we could have interacted with is a container. But over here in Kubernetes, we have the least entity as a pod. Okay. Okay, pod. We are calling it as a pod. So why do we need pod? So understand one thing. What used to happen with Docker? Let's say you have one feature to work upon. Let's say you have login feature. You want to create or host a login feature. Then you may have different containers running on for login feature, isn't it? So probably first container will store authentication part only. Your second container may contain the web services for forget password, right? Your third probably will contain for sign up link, right? Something like this. So when all of these containers will be running, then you can say that, okay, my complete login feature is up and running. Correct? This complete login. Yes, exactly. CAPTCHA and all other thing, right? Whatever micro features will be there in login module or login feature, all those will be will be hosted in different containers, right? Because they do have a logical dependency upon each other. Correct? So if you want to make sure that your login feature is working correctly, then what does it mean? You will have to make sure that all these containers are up and running all the time. Correct? Now, if you want to create any logical group, right? Just to make sure that how you can create that in Docker, it might be very tedious. So just to simplify all these problems, Kubernetes introduced pod. Pod meaning what? Pod is just a container of a container. For simplicity, you can consider pod is something which can contain your containers. How many containers? Any number of containers. Okay. It's up to you how you want to logically group your containers. Okay, and that wrapper is called as an pod. Okay, pod. So understand, guys, this is something what? This is something we are saying as a pod, which can contain one or more containers. Okay, is this clear to everyone? Okay. Okay, it's like tree data structure. No, you cannot say like that, but you can simply say it is kind of stack, which is containing all the containers. Okay. All right. Everyone is clear with pod? Please respond so that we can go ahead and we can talk about next. Okay. Now this is pod. Understand the purpose, guys. Okay. Understand the purpose. What is the purpose of pod? Purpose of pod is grouping multiple containers logically. And one pod will contain one or more containers, which we will define. We will tell which all containers has to be there in that pod. Point number one. Second, let's say when you will now, this pod is a group of this container. If you delete this pod, what's going to happen? If you delete this pod, what's going to happen? All the containers in this pod will be gone. Correct? Right? So you also need to understand by grouping it, you are also telling Kubernetes that whatever action you will take on this pod will also be applicable to all the containers within that pod. Right? This is one. Let's say you want to run multiple replicas. You want to run multiple replicas of this container, basically of this pod. Okay. This is where another object comes into picture, which is replica set. Okay. So if you want to visualize replica set something like this. This is your replica set, which will contain one or more pods. Okay, it will contain one or more pods to create multiple replicas of this pod. Okay, this is what we say replica set. Okay, all right. Again, just like pod, whatever action you will take on this replica set will be applicable to all the pods within that replica set. All right. Replica set is clear to everyone, guys? Okay. Now, if you want to deploy replica sets, one or more replica sets, that's where another third object comes into picture, which is what? Which is deployments. So let me just resize it. Okay, so another, if you want to run multiple replica sets, okay, for deployments and all those purposes, then you have another thing, which is basically called as an deployments, as another Kubernetes objects. And these deployments will contain nothing but multiple replica sets. Okay, these are deployments. Okay, and to manage deployments, we have something which is called as a service. Okay, which is called as a service, where you may have one or more deployments. You may have one or more deployments within it. Okay, is this clear, guys? How this hierarchy, contains each other? Containers, pods, replica set, deployments, and services. Is this clear? Okay, hold on. Just right now, just focus upon, first of all, focus upon this concept. Try to understand this concept first. How and where it goes, we'll see everything. Don't worry. But right now, just focus upon this. These concepts are clear to everyone. Pod, right? Pod, replica set, deployments, and services. Is this clear? Everyone is clear with this? Okay, perfect. Thank you for responding. So now, let's take a quick break, guys. Okay, I want you guys to settle down with all these discussions we have done so far. Okay, so please settle down with all the discussions, settle down with the concepts. If you have any questions so far, then please form a question and just put in the chat window, and I will pick it up and I will answer all of your questions one by one. Okay, once we are back from the break. Okay, and as usual, break would be for 10 minutes. Okay, and we will resume by 8:10. All right. So I will also put down timer. Okay, so let's meet by 8:10, guys. And please feel free to put down all the questions you have in the chat window. Okay, thank you. All right, guys. So let's resume and let me pick up the questions. Okay. So first question is how to recreate containers. Okay, how to create containers. So that's why we will be going ahead and we will be writing down our Kubernetes definition files. Okay, I will show you shortly. So how to write down Kubernetes definition files by having a quick demo of all of these 4 objects which we talked about. Okay, that is pod, replica set, deployments, and services. Okay. Then the second question is where can we place our node? Okay, we just need to tell Kubernetes, right? And then Kubernetes master will decide basically where on this cluster which we have set it up. Okay, on this cluster itself, on which node it has to place whatever pods or deployments or services or replica set we create. So this is Kubernetes master's responsibility to decide and to run whatever object we want Kubernetes cluster to run. Okay. Then, okay, recordings. Okay, but you will be getting recordings in your LMS as usual. Okay, you can anytime go ahead and have a access to recording. Can we have 2 or more KTest master node? If you want, you can have it, but what is the purpose? As we are using this managed service, that's the beauty of using managed service. We don't have to go and we don't have to manage or maintain the Kubernetes cluster. If you're using any cloud service, it becomes cloud provider's native responsibility to make it up and running all the time. Okay. But if you're creating your Kubernetes cluster on premises, then in that cases, yes, it is pretty much possible that you would like to go ahead and you would like to create 2 or more Kubernetes master nodes to maintain the high availability. Yes, you can do that. Cloud has the KTest master setup and minion site. Yes, minions means your nodes. So first we created, if you understand, we created the Kubernetes cluster, EKS cluster. That's what your Kubernetes master is. And then we have added the worker nodes. That is nothing but your nodes or minions. Okay. And second question, are we controlling kubectl from local machine? Yes, I have installed kubectl on my local machine. And from that's where I will be controlling my Kubernetes cluster. Okay, basically I will be passing on whatever commands I want to pass on. Okay. So basically kubectl or kubectl or kubectl, whatever name you would like to call it by. So you need to install that kubectl on the machine from where you want to connect to your cluster. Okay. How many pods we can add in a node? Any number of pods or any number of deployments, any number of services you can configure in your Kubernetes cluster. There is no hard and fast limit to that. Only thing is it should have the required configuration to run. Just like your Docker Swarm cluster. If you have only 1 GB RAM, so you can run containers up to 1 GB. Just like that, if you have whatever configuration you have to your cluster, you can run all the pods and all the Kubernetes objects up to that limit. If you want to run more, then you will have to add more nodes or you will have to scale in your Kubernetes cluster in terms of hardware requirements. Okay, any more questions, guys? Any more questions we have? Okay, so there are no questions. So let's go on, guys. Let's move on and let's try to see how we can write our Kubernetes clusters. So I do have a couple of demos prepared for you, looking at the time. Okay, so first of all, any Kubernetes definition file has 4 more important components. So first is API version. Okay. Second is metadata. Okay. And the third is kind. and fourth is spec. Okay, so let's understand what these four component means. Four important components of any Kubernetes definition file. So I told you that we have four important objects, right? Which is pod, replica set, deployments, and services. So all these objects, if you have to configure them, so all these objects are provided by some certain APIs. Okay, some certain APIs. So first of all, what we have to do is we need to define kind of a Kubernetes definition file, meaning what we are trying to do from this Kubernetes definition file. Do you want to create a pod? Then kind will become pod. Do you want to create a replica set? Okay, do you want to create a replica set? Then kind will become replica set. Do you want to create deployment? Then kind will become deployment. Do you want to create services? Then kind will become service. Okay, so kind defines what kind of Kubernetes definition file we are trying to execute. Okay, and depending upon the kind, it might be pod, it might be replica set, or it might be deployment, or it might be a service. So depending upon your kind, you need to provide the API version. Let's say if you're there are two API versions. So first is V1 and another is apps V1. Okay, these are versions of an API. Okay, so generally V1 and deployment comes the like pod as a kind, and deployments comes into API version V1, and replica set and services comes under apps V1. What do we mean by that? If you're using kind as in pod, okay, you're using kind as a pod, then API version you will write down as a V1. Okay, because version 1 is the API version which provides pod. So just like that, you will have to provide this information. Okay. Then metadata. Metadata meaning what? The information about this pod. Okay, information about this pod. Okay, what kind of name you want to give to this pod and everything you will give in the metadata. And then specification, meaning what? One more thing to clarify, metadata means what? The information about your kind. In this case, I have written down kind as a pod. So if I specify metadata as, let's say, name my pod, then this pod will contain name as in my pod. Okay. If you are written down deployments, then the name of the deployment will become whatever name you have given down. Okay, so it is nothing but an information about the kind, information about this pod, this deployment or replica set. Okay, then specification or specs. So these specs contains what this pod should contains. For example, how many containers this pod should contain. Okay, name of the container, Nginx, and what should be the image. Okay, all these things you will specify about pod or deployment or replica set or services, any kind you will write down what that particular kind should contain. Okay, that's what we will specify in specs section, specification section. Okay, is this clear? The structure of this Kubernetes definition file, is this clear, guys, to everyone? Okay, thank you for responding. Now you need to understand one thing. Once you have written down any Kubernetes definition file, understand one thing. Okay, what you can do, it might be any kind of Kubernetes definition file, might be a pod, a deployment, or a replica set, or a services, any Kubernetes definition file. Either you can create, or you can update, or you can delete, or you can get more information about whatever objects you are running. Yes or no? These four operations you can do, basically CRUD operations. Correct? Right? Now, let's say in according to create, I'm telling you a simple analogy. In according to create something, the command is create. Okay. In according to update something, command is update. In according to delete something, command is delete. So when I'm saying these are commands, these are basically an API which you will be invoking using kubectl. Okay. So delete. And if you want more information about it, okay, so just like we have inspect in Docker, here we have get command, get. Okay, is this clear? These 4 basic operations are clear to everyone? Cool. Guys, I can see many people are not responding. Please respond. Okay, so these are 4 basic operations. Now, how many kinds of object we have? We have pod, we have replica set, we have deployment, and we have services. Correct? We have these 4, basically these 4 objects. Now, if you want to do any kind of operation on these 4 objects, first thing is very clear to you. Let's take an example of pod. Okay. If you want to create a pod, or if you want to communicate with your EKS cluster, which utility you will use? Kubectl. Correct? Which utility you will use? Kubectl. Correct? Now, you will have to execute any command using kubectl. So kubectl, let's say I want to create a pod. Okay, so my command will become kubectl create and your definition file, whatever definition file, path, give path to that definition file. Let's say I'm saying demo.yaml. And assuming that this pod demo.yaml contains information or Kubernetes instructions to create a pod. So my command will become kubectl create your file name. If you want to, once the file name is you have given, and once you execute the command, what will happen? It will create a pod. Okay, it will create a pod. If you want to get more information about this pod, how you will do that? Kubectl get whatever pod name you had. Let's say I have given pod name as my pod. You will give my pod. Okay, if you want to get information about all the pods, then you will simply write down kubectl get pods. Right? If you want to delete this pod, kubectl delete pod. And which pod you want to delete? Give your pod name. I'm saying my pod. Okay. And if you are to update something, so update your, just like we used to update using Docker file. So update your Kubernetes definition file. And sorry, my bad, for update, we have apply command. And write down over here, kubectl apply, and give your new instructions. Pod demo.yaml. Is this clear? How you can interact? Okay. So if you have understood this, then if this is for pod, if these commands are for pod, for replica set, how this command you will execute? Kubectl create your replica set file, kubectl get what? Replica set, kubectl delete whatever it is, right? Replica set and your replica set name. Okay, and kubectl apply. If you want to interact with deployments instead of pod, what you will do? You will use deployment, right? If you want to communicate with services instead of pod, you will use service keyword in the commands. Is this clear, everyone? Okay. Now, one more little shortcut I'm telling you. In according to write down replica set, sometimes it becomes very lengthy. You will have to type a complete replica set keyword. So Kubernetes gives you shortcut RS meaning replica set. So instead of using replica set, you can also use RS only, kubectl get RS. Or for services, shortcut is SVC. The abbreviation is SVC or services. You can use any one of them. Okay. All right. So now, if everything is clear, having said that, okay, let's head back and let's see our 4 demos, how you can go now. You can see that. Okay. So first of all, I will see kubectl get SVC, meaning what? I'm now invoking services. Kubectl get SVC and some services are running, meaning my Kubernetes cluster is up and running. Okay. So now let's look at this pod demo, the first, file I will tell you. So how to create pods. So just like I told you, okay. So Kubernetes definition file has 4 important aspects. Just like we discussed, first is API version, kind, metadata, and spec. 4 important objects in a Kubernetes definition file. Okay. So I'm saying I want to create a pod. So kind, what kind I will write down? Pod. P capital, pod. Okay. Pod has been provided by API version V1, small v1. So I have written down API version v1. And the metadata about this pod, I'm saying the name of this pod, I'm saying name of the pod is Nginx. And labels, I want to give my own custom labels, okay, just to identify the pod. So I'm saying app Nginx, I'm running into this tier front end, okay. It is just for my identification purpose. Okay, you can give your own labels. That's not a problem. There is no fixed format. Only fixed format is key and value. Key and value. So whatever labels you want to give, you can give it. Okay. So this is metadata about my pod. And in this specification, I am saying, let's say I want to run only one container in this. Let's say name Nginx, name containers. In this specification, I want to run containers in this pod. And only one container. So name Nginx and image of the name, from which image this container should run. So I'm saying Nginx and stable pod. You may wonder from where this image gonna come. So this image gonna come from open source Docker repository, which is hub.docker.com. Okay, it gonna come from Docker Hub itself, just like we used to do with the Docker. Okay, and save this. Now let's first check. Do we have any pods running? How can I check? Kubectl get pods. And you see no resource found, meaning what? There are no resources. There are no pod running. Now I want to basically go ahead and execute this Kubernetes definition file. Okay, so I will say kubectl apply and path of this. So I'm saying path is in the pod folder, pod demo.yaml is the path of my Kubernetes definition file. Now, there is one fundamental difference you will have to understand. Okay, so -f, okay, the file. First is create command. There is a difference between create and apply command, create and update. Okay, what is the nature? If you're using create command, then it will only create the resource. Okay, understand how create command is working. Kubectl create -f file name and give your file name. Okay, so create command, the nature of create command is what? If the resource does not exist, it will create the resource. If resource does not exist, it will create the resource. If the resource already exists, it will give you an error. It will only create. Okay, it will not be able to recreate. It will only create the resource if the resource does not exist. If the resource does exist, then it will give you error. The command will fail. Whereas, what is the nature of apply command? It will check that resource is exist or not. If the resource does not exist, it will create the resource. And if resource exists, then it will update the resource. Okay. If the resource does not exist, it will create the resource. And if resource does exist, then it will update the resource. Okay. Do you understand, guys? So this is exactly why you will see almost every time, instead of using create, we will use apply command every time. Okay, because it by default, like, takes care of everything. If the resource does not exist, it will create it. If the resource exists, it will update the resource according to my Kubernetes definition file. Okay, so I'm saying kubectl apply and my definition file, and as soon as you hit enter, it will go ahead and it will connect to my EKS cluster, and it will create a pod, which it has created. Can you see the output? Pod Nginx created. So now if you see kubectl get pods, and if you enter it, you will see the information that Nginx pod is running, and how many containers? Only one container, and one of one is running. All right. And this is the age, when it got created. Okay, so it will give you information. Now, if you want to, let's say, get more information about this Nginx, the command is kubectl get pod, and which pod you want to get more information about? Nginx pod, the name of the pod. If you hit enter, it will give you the more information about Nginx only. Okay. So that's how you can go ahead and you can do that. Let's say you want to delete this pod. So you need to go kubectl delete pod, and which pod? Nginx pod you want to delete it. So delete. And now if you see get pods, we shouldn't have any resources running. You see no resource found. All right. Is this clear? Okay, this is how basically you can create a pod. Okay, now let's say you want to create more, you want to run more containers in the pod. So you can always write down in the specifications saying that I want to create another. So I'm saying busy, or I would say Redis container, and I will go ahead and write down it should run from Redis image. Okay, just save it. And again, in according to create kubectl apply -f pods and pod demo.yaml. Okay, pod has been created. And if you see kubectl get pods, you see now Nginx pod is running two containers. One is Nginx and second is Redis itself. Okay, so you can go ahead and you can update any given point in time, and you can simply execute those Kubernetes definition files. Okay. Now I'll simply go ahead and simply delete the pod. Okay. And now if you want to, let's say this is about pods. That's how you can interact or create pods, delete pods. All right. Now, if you want to, let's say, create a replica set. Okay. If you want to create replica set, then the Kubernetes definition file will look like something like this. So let's say again, 4 important Kubernetes definition file. Okay. API version, kind, metadata, and spec. Right. So kind is what? Replica set. What is replica set? We can run multiple pods. We can run multiple pods in one replica set. Okay. So if you want to do that, we need to create replica set. So I'm saying I want to create replica set. So that's why I have placed kind as a replica set only. And which API provides replica set? Apps v1. apps/v1. So I have given that, and metadata about this replica. Okay, so I'm saying metadata is this is a demo replica set, name as a demo replica set, and labels I'm saying app, my app, just a custom label I want to give so that I can identify if I want to. Okay, and in this specification, now you need to understand one thing. In this specification, what you need to do is specs Selector, meaning what? How many replicas? First, how many replicas it should run? I'm saying it should run 6 replica of a pod. How many replicas of a pod? 6 replicas of a pod. Which pod? We will tell. We will tell this replica set which pod. But for now, I want to run 6 replicas of a pod. Perfect. So which pod, right? How there might be like hundreds of pods running in your EKS cluster. Which pod? I mean, this replica set should run 6 copies of which pod. So I am saying selector means select and match the label. This tier front end. So whichever pod will be having this label, whichever pod having this label tier front end, this replica set will run 6 copies of that particular pod. Understood? And now the template. Okay, so you see metadata specs. This is your pod definition file only, isn't it? Correct, guys? Right? So here I'm giving tier front end, right? So this is the pod. All right. So once you have written down your Kubernetes definition file, again, to deploy or to update, you just need to execute Kubernetes apply. And now I will give replica set and demo replica set the Kubernetes definition file name. Okay. So I have written down and say enter. And you see a replica set has been created. Okay. So if you want to get more information about replica set, so simply kubectl get is the command to get more information. And of what? Type replica set. Okay. You see demo replica set, it is running 6 copies. Or instead of replica set, you can simply also type down short form, which is RS replica set. Get RS. It will give you this. Okay. Or if you want to get more specific information, then let's say only kubectl get replica set. And which replica set? Demo replica set. Hit enter. And you will get more information. All right. If you want to delete this replica set, okay. If you want to delete this replica set, what command you will have to execute? Anyone? Anyone can tell me what command you should execute if you want to delete this replica set? Kubectl delete, right? Kubectl delete. But what delete? Kubectl delete. What? What need to be deleted? What need to be deleted? Replica set has to be deleted, correct? Replica set. So either you need to type down complete spell replica set, or you can simply say RS replica set. And which replica set? Oh, my bad. Kubectl delete replica set and demo replica set. The name of the replica set which you want to delete. And you see the replica set has been deleted. Okay. So this is how this replica set works out. Now for the deployments, okay. For the deployments, the syntax of replica set and the deployment is identical, is exact same. If you see over here, API version, kind, metadata specs. Now instead of replica set, you will use deployment. It comes with apps v1. Okay. In metadata, again, you will give the information about deployment. Okay. And in spec, you see same thing, selectors and replicas you will mention. Okay. Only thing is the difference is kind is deployment you will have to use with deployments. Okay. And again, if you want to apply or deploy this, so kubectl apply -f, and you will see deployments the path of this Kubernetes definition file. Okay, and simply say enter. Okay, so you want to see if the deployment has been created or not. So simply say kubectl get deployments, and you will see demo deployment. And just like that, if you want to do some certain changes, change your Kubernetes definition file. Okay, change your Kubernetes definition file. For example, let's say I want to change this Kubernetes definition file. So instead of Nginx, I want to use 1.21.0. Okay, so save and reapply the changes, and you see demo deployment has been configured. First time when you executed it, it said created because deployment was not existing by that time. But now when you are re-executing with the new changes, you see, do you understand now the nature of apply command? Now, as the resource has been already exist, it is just updating, right? Configuring it, reconfiguring it. Okay. Understood? Okay, so once you are done, simply say kubectl delete deployment, and I want to, okay, a spell mistake, demo deployment. This is also one of the handy syntax. Okay, so this is how you will update your deployments or create your deployments. All right. And lastly, for services. Okay, so there are types of services. Let's say you want to open up your ports, just like in we used to do with Docker. Then you can have these services. Okay, you can use these services. Okay, so there are three types of services: node port, load balancer, or host. So you can use any of this, and you can simply configure your services. Okay, and similarly, just like we used to deploy pods or deployments, you can simply deploy this file using kubectl apply. Okay, perfect. So this is basically at a very high level, guys. At a very high level, that's what Kubernetes is, and you can interact with Kubernetes. Okay, so please understand Kubernetes is a very vast tool. Okay, very vast orchestration tool. All right, and generally there are three aspects of Kubernetes, and there are also certifications available from CNCF Foundation to understand and to learn Kubernetes. And there are three parts to it. There are three different parts to it, paths. First is administration, which is also known as CKA, Certified Kubernetes Administrator. Second, there is another path, which is basically a developer and also known as CKAD, so Certified Kubernetes Application Developer. Third is CKS, so basically Certified Kubernetes Security Specialist. Okay, so these are learning paths for Kubernetes. So whichever is suitable for you, you can go for that. But at a very high level, I just wanted to give you a flavor of Kubernetes and as a very, very basic idea from 10,000 feet as a bird's eye. Okay, there are so many more things to Kubernetes than what we have discussed. Okay, this is just bare an introduction. Okay, so this is what Kubernetes, guys. So do you have any questions so far? Any questions, guys? Okay, let me open up a chat. So one question I have, can we see any changes on AWS after execution of the command? I do not understand your question. Can you please elaborate a little bit? What kind of changes you want to see? Just you can see the monitor. You can monitor all these things, that how many resources are getting consumed, right? How many resources are getting consumed? What is the load? right? What's the GCP utilization, everything. You can always see like, all these kind of like, monitoring aspects you can see. Okay, so I do have another, what is ingress controller? So I will explain you in a simple sentence. So ingress controller is a special type of load balancer for Kubernetes. Okay, not only Kubernetes, but any kind of containerized environment. If you want to like, balance your load. Okay, so that's what ingress controller is all about. CNAME and names and C groups. Okay, I cannot give you the example. It itself is a very vast topic. So, but namespaces are something like logical grouping. Just like if you are a developer. So I will. Are you a developer? Who is asking this question? Okay, so if you're not from a development background, then if you want to, let's say, logically group your all the Kubernetes objects, then that's what you are like, you will be using your namespaces. Okay, so that's what the namespace is. Can we use KTS only automation perspective? Automation meaning what? Kubernetes is an container orchestration tool. You can use Kubernetes to manage your containers effectively, just like Docker Swarm. Okay. Cool. Any more questions, guys? Okay, Docker or Kubernetes, which is best to use? There are two answers to this. So if you understand from an industry point of view, many people are now moving ahead with Kubernetes. Okay, and obviously my personal experience is Kubernetes provides you way more feature over Docker Swarm. Okay, but it's up to you that like which way you would like to go or which container orchestration you would like to use. As far as like my personal opinion is, I don't know what others are like at personal level. My personal opinion is yes, obviously Kubernetes is the best thing I came across when it comes to container management. Okay, it is not only management, but you have many more plugins available when it comes to deployments and managing the container fleet when it comes to Kubernetes. Okay, and as it is open source, you don't need to pay. So yes, there are plenty of reasons why you should go for Kubernetes. Okay. How to connect Kubernetes with VS Code, meaning what? I never connected Kubernetes to my VS Code. I'm just using this VS Code as an editor to write down my files. Okay. I'm just using this shell, which is basically Windows native shell, which VS Code like provides you. And I'm just, as I have already configured, I'm just executing my Kubernetes commands from here. VS Code has nothing to do with it. Cool. Any more questions, guys? Any more questions you have? Any doubts? Nope. Okay, then. So guys, that's where our series of this EDL series for the DevOps comes to an end. Okay, so we thank you all of you to part of to being part of this EDL series, and we hope you must have enjoyed. Okay, you must have enjoyed the sessions. Okay, so thank you guys for presenting and being present and asking so many questions. So thank you for your active participations. Thank you for attending all the sessions, and thank you for your time. And that's where I will conclude. So one more time, thank you guys, and keep learning. Keep visiting our portal and website. And if you have any questions so far, you can always get back to our support team. Those people will be very happy to answer your questions at any given point in time. Okay. So thank you. And thank you for your participation. So handing over to you, Amar.
Yes.
Yep.
Thank you so much, Bhaskar sir.
Thank you.
So students, we are done with the DevOps agenda. From tomorrow, we are going to start with automation testing on same time. and trainer name is Rajni. So we will start automation testing from tomorrow. Okay. If you have any question, then please post in chat box. One question is there, do I need to register for that? No, on same classroom, we are going to take automation testing. Okay, DevOps and automation is combined. One more question is there. Please share the recordings as soon as possible. Yes, everyday recording, Venkatesh, everyday recording is already uploaded in the LMS. Please check your LMS. So guys, we are going to start automation testing from tomorrow. Yes, onward 8 days. Any more question? Deepak, I have enrolled today and attending my first session to get the. So Deepak, 60% attendance is mandatory for getting the certificate. So I have one more question for DevOps material not yet uploaded. Actually, there are not more any material for DevOps. So we will upload for the automation testing, okay? Because most of the data which is covered on the diagram tool by Bhaskar. So yes, so for tomorrow, same link, Zoom link we are going to use for automation also. Same process, same classroom, everything is same, just we are going to change the topic. Any more question, guys? Yes, Venkatesh, you are welcome. I hope everything is clear now. So we will meet on tomorrow's same time at 7 o'clock. Yes, so Natarajan, you can now wind up the session now. Thank you guys. Bye.